Gather round. It's story time. All right, we're going to go in the way, way back machine. We're jumping in the way, way back machine, going back to Mr. Slagle in hike school. We got to tell you a story. So, God, it must have been senior year. I'm sitting in class. I'm trying my best, trying to get good grades, do what I can. And, so I get a pass from an office aide, comes into the classroom. And I'm like, I never get a pass. What is this? Someone's thinking of me? Someone has me on their mind. They want me to leave my current lesson and go somewhere else in the school. I start to get excited. You can imagine now. I'm like, whoa, what's happening? Where are we going? God, man, this is going to be fun, right? So it's to the counselors. I get to go down to the counselor's office. And I didn't get to see my counselor very often. This was at Lathrop. And I think we had like 1,400, 1,200 kids at the school at the time. To put that in perspective, there's currently, North Pole usually has between 600 and 700, around maybe a little more than 700 kids. So almost double the size, right? So I seldomly got to see my counselor. Anyways, I go down there. Counselor says to me, "Hey, Slagle, we noticed that you've been doing pretty good in your math and science classes. We want you to apply to go to the Colorado School of Mines for engineering." And I was like, oh, someone wants me. Someone thought of me for the Colorado School of Mines. So then I go back to class. Flash forward 2 hours, lunchtime. Go up to my buddy. I'm like, "Hey, Billy, I see you also got the same thing. You know what? We could go to school. We could both go to school together. We could go there. Let's go down and apply right now." All right. So we're sitting there. We're typing up our applications to get into the Colorado School of Mines. And I look over at Billy and he says, First question. Why are you interested in becoming an engineer?" Or something along those lines. And Billy looks at me and goes, "You know what? I don't even know if I should be an engineer. I don't know much about engines." And it was right then that I knew I did not feel prepared to fill out the application for the Colorado School of Mines because I didn't really know what an engineer did. It seemed confusing. I wasn't sure what to write for that. I didn't know much about the careers that were available to me. And I have this picture of an engineer from Team Fortress 2 here because in our minds we think engineer, maybe this is the image that pops into our head. Some 5 o'clock shadowed guy with a hard hat on and a giant wrench. And that's not necessarily an accurate portrayal. First of all, you're typically, engineers maybe aren't always in the field. A lot of times you're sitting in an office and doing other things as well. You might be in the field for some of the time, but maybe an engineer doesn't always get their hands dirty either. A lot of times they're doing a lot of the behind-the-scenes work and leave the dirty work for others. What they're doing is trying to keep people safe. So what I'm going to go through today are we're going to talk about what does it mean to be an engineer? What do engineers do? And we're also going to watch a short video, and I'll link that on the website. So that was my story. Real fun. What a fun story. Let's go ahead and let's take a look at engineering as a whole. We're going to learn some vocabulary. What does engineering mean? Okay, it's a really broad definition that's not very specific. You're basically a problem solver. Engineering is the process of solving problems through the use of math, science, and other practical knowledge. Okay? You're solving problems, right? Aren't I? I'm a teacher. I'm an educational engineer. That's what I am. And you see engineer tacked onto job titles all the time. Okay? problem solver. Isn't that what work is? Work is just solving problems, right? So it's a very vacuous name for a job. So if someone says they're an engineer, that really doesn't mean anything. You need to pry and ask them more questions. What kind of engineering do you do, right? The process of solving problems through math, science, and other practical knowledge. However, you can do these things. It's not necessarily good engineering. Here's an example. Well, it looks like Fairbanks has got a buildup of plastic bottles and they're taking up a lot of space. How about we get rid of these plastic bottles? Hey, I've got an idea. Why don't we pour some gasoline on them and torch them, right? That's a solution, a simple solution, but it has a lot of consequences. So what is good engineering? Does it solve the plastic problem? That did. What is good engineering, though? Good engineering is solving the problem like lots of waste plastic while maximizing the safety of others. So lots of burning plastic's probably not great for the air quality. You're minimizing the effect on the environment. Might be hard to clean up something like that. And you're also minimizing cost. So sometimes when you minimize cost, you don't take safety precautions into effect. It costs money to be safe, right? It costs money to get safety equipment. It costs money to make sure no part of the environment is damaged when you're doing a project. So good engineering, you're trying to solve these problems in a way where no one can get hurt and the environment isn't hurt, and you can do it as cheap as possible. So I love simple water purification systems are fantastic because they're cheap to make. They don't harm the environment, and they get people the good water that they need, like the Life Straw. The Life Straw. I actually don't know how effective that invention was, but it was a great invention because it's so simple and it gets people the water that they need, right? Fantastic. That's good engineering. Okay, so how does an engineer spend their time? This is from an older study that I found. But what I got to say here is when you guys are in high school, there are very few careers where you graduate high school and they're looking for just a high school graduate. Your learning journey is kind of beginning with high school. And I know you're probably thinking, I don't like school. Maybe some of you are thinking that. I'm not sure. What do I want to do after high school? That's okay. That's okay. You're in high school to learn how to learn. And this graph kind of sends that point home. Even as an engineer, 50% of your time is likely to be spent designing. Now, does it say building? Not really. It says designing. So maybe the engineer is not actually building. It's, the engineer is trying to get everything looking nice, right? Looking nice aesthetically, but also functionally, making sure they have something very well designed. Look at the other chunk, okay? Other chunk of time, understanding stuff and finding stuff. This is like learning. This is like you're going to have to adapt. You think about being a good engineer, and that means you are reaching everywhere you can to get the newest information, the newest technology, the cheapest technology. And that's changing every day. And you're trying to put that into what you're designing. You want to be up to date on what you're doing, which means you have constantly got to be reading. You've constantly got to be learning. And if you want to be a competitive engineer, that's part of the job, right? Got to stay up to date. And then you take that once you've done all your appropriate research and you incorporate that into your design. That's engineering. And if you have this image, what I don't want you to do is go spend a bunch of money at college for engineering and find out you don't like it. I want you to know what's for you and know what you're doing. Now, if you like doing this kind of planning and designing and creative problem solving, it might be the right job. And different types of engineering, this chart is going to look different, right? It just depends on what you are doing. Okay, what kind of engineering? And we're going to kind of go into that as well. Okay, when there's a problem that an engineer solves, This is a word you're going to hear me say over and over and over again. And then they make an initial attempt at solving that problem. That initial attempt is called the prototype, right? It's an initial model of something from which subsequent forms are developed, copied, or improved upon. I think, the prototype's kind of relative to the developer. Like, there was the very first cell phone. That's not like the only prototype. You can have like a prototype iPhone 7. It's like the first model of the iPhone 7 or iPhone whatever. I don't even know what we're on. X triple squared or whatever it is now. Anyways, you can put out an initial model, and then you're going to take that model and you're going to test it and put it under pressure and give it to people to look at and see what happens when it breaks. And then go back and fix all those things and do that again, and then send it out for people to look at and see what problems come up. And that's what the prototype is for. And making that prototype a lot of times can be the hardest part about designing a solution to a problem. So that is the word prototype, that initial model of something. Constraints. I have a picture here of, Iron Chef. You see these a lot of the time on cooking shows. A constraint is just a set of limitations or constraints. So they may be like, you need to make breakfast, but you have to use, let's see here, Funyuns, octopus tentacles, and mayonnaise. Go. And then they turn you loose, right? So that would be a rough breakfast, but those are the constraints, the materials or the ingredients that the chefs have to cook with. Now, as engineers, there are lots of constraints that engineers face all the time, and the big ones are usually time, materials, and cost, and those materials and cost are pretty tightly related, and the law, right? And safety. There's all these constraints that you need to be thinking about when you're designing a solution. You can make something that's really safe, but it's going to exceed your cost constraint. Or you could make something that's going to be really safe and really cheap, but maybe it would take a lot longer than what you have, right? So you have this time constraint that you're operating under. Now, when you take all those things into account, maybe only a couple different designs are going to fit the bill for what you're doing. So understanding the word constraints, these restrictions, these limitations that are on a system, is what engineers do. So they look at all of the overarching rules in a design, and then they go in and they start. So that's where the learning, the understanding portion of the engineering job comes in. Okay, let's take a look at these disciplines. I don't know what all these are, but I'm going to give you the basic rundown of the main categories and talk about kind of what it is that they do. So civil engineers are dealing with, kind of developing, these are disciplines of engineering, but then there are like sub-disciplines, right? They're developing kind of like infrastructure for a city. That could be like roads. It could be infrastructure for like a mine. It could be for some sort of structure like a bridge or a building. All sorts of stuff. It could be dealing with waste like poop. All sorts of different things that you could be designing with. Just tiny little details about a road. There are many, many ways to make a road, and it really just depends on what you're building on. So lots of building and concrete and materials go into building a road that you might not think, especially if you're in town and you have to deal with like manholes and where people are going to access stuff that's underground. It can get pretty complicated pretty fast. So that's what civil engineers do. Structural would be like for bridges and buildings. Mining. Now, each of these subcategories has even more subcategories. But like mining, you could be specialized in ventilation. Maybe you are interested in just doing ventilation for mines and managing a ventilation system and making sure that everyone that's in the mine is safe and has healthy air to breathe. Back in the day, they'd bring down candles. The candle went out, they run out of oxygen, get the heck out of there. Not a very safe way to do things. Okay, environmental, dealing with, looking at a piece of land and making sure you have a proper way to dispose of waste for a project or something along those lines. So lots of different things that you can do. Mechanical engineers typically are kind of the designers of the things that we use. So anything mechanical, even as simple as like the chair I'm sitting, has probably been designed by a mechanical engineer. And since there are so many items that are being created that have moving parts and pieces and are drawn and created, those are done by a mechanical engineer. And so there's usually a high demand for mechanical engineers, and there's usually a lot of people that are interested in mechanical engineering. So when you see the typical engineer, a lot of people think mechanical engineers, but that's not necessarily true either, because you could be working on ginormous power grid systems controlling and distributing power to thousands of people, or you could be designing something that's in a cell phone, looking at tiny circuits that make up a more complicated machine. So electrical engineering has a wide range of things that you can do as well in designing computer systems. So you're looking at these problems, you're trying to improve upon previous products, and looking at making really just the world a better place in general. So pick which area of the world you want to specialize in if you're thinking about becoming an engineer. Okay? There's a basic rundown. This is the most recent data I could find quickly. There's probably more recent data out there. But here's the undergraduate enrollments by discipline. This is from 2014 to 2015. Mechanical, electrical, civil, like mechanical's number 1, electrical's number 2, civil. Now back, the old data that I had, these two were flip-flopped. And I think just the more prevalence of electronics, probably a higher demand for electric and computer engineers. And what does UAF have? Which degrees does UAF have? They've got a mechanical program, they have an electrical program, they have a civil program, they have computer science, they have a petroleum program, and a very successful one at that. And we have a brand new engineering building at UAF. It's amazing. And they have a mining and environmental, civil environmental engineering, mining. So not many mining engineers. That's because there aren't a whole ton of mines, not as many as there are, for example, like startup firms that are building some new product, right? Cool. So the different kinds. Another thing that's important to talk about is our engineering design process, and we're going to do this over and over and over again in this class. Okay, the engineering design process begins with those constraints that I was talking about before. You have a problem, and that problem needs to be solved under a certain set of constraints. And so, for example, with our bridge building project that we did, I've done like a boat building project in the past too. But with the bridge building project, our constraints were, it's due on this day. We have this many days to do this. You are given this paper, this tape, so on and so forth. So we identified those things. We went over all the rules, the constraints were also the rules, how we were going to do the competition, so on and so forth. Once we understood that, we could start researching maybe different ways to make a bridge. What are some bridge designs that other people have done? How do I think I could take their design and other people's designs, maybe combine them together? So get our brain, do some research, learn about the field, what's going on with bridge building. Once you have that information, you can start to say oh man, I could do this or this. Well, which one's better? I'm not sure. Or this, I could do this. You have a bunch of options, right? So you look at all the options, and then you select one or a combination of those options that you think you like. And in selecting one, you can then start, and these don't have to be these can be, this solution, the promising solution could be something brand new, okay? And you're going to take that solution and you're going to make an attempt at it. That's what you do during the create phase. So you're going to take and you're going to build a prototype. Now, once you have your prototype, so we built our bridge, right? We looked at maybe some other bridges. We looked at different plans, different kinds of strategies that we might be able to go. We maybe thought about one for a couple seconds and then ruled it out. We selected one we wanted to try. We built our prototype. And then we put that prototype under stress. And we put it across maybe a tiny little test gap, put some rocks in the middle to see if it could hold any weight. Maybe it failed. Maybe it did really well. Maybe it did okay. But you figured out, you can always test something until it breaks. So it breaks, and then you try and fix that issue. What little thing can I tweak? Maybe if I add a little support here, my bridge will be stronger. And then that problem, the problem that you need to fix, starts the engineering design process all over again. And then you can research, my bridge broke here. How do people support spots that are in this location or this shape? And go back through and come up with solutions to that problem until you have looked at every little aspect of your bridge and made it as good as can be. Okay, so now you get to watch this video. Video is linked on the website. You can answer the questions that are in Google Classroom. So, with that being said, sayonara. Thanks for watching. And there will be more videos to come and incredible content from the Mathnasium. So, guys, we'll see you later. Have a great weekend.